Hey everybody, today we'll do another problem, and today we will do AC circuit. It's going to be not too bad problem. So we have a circuit like this. So we have a circuit like that. And then we have a resistor that we don't know the value of that resistor. And then we have another impedance. And this impedance right here is called CL, C load. And then we have something like that, right? So the only thing that we know is the power. We have 40 kilowatts. We have a 10 kilowatts, and we have the voltage, right? So basically, that's all we know, right? And we are asked. It says that a circuit consists of a pure resistance of a pure resistance right in series with an unknown impedance in series with an unknown impedance that's what they're talking about, this right here. And you notice that they both unknown, they're just not telling us. This one is unknown too, we don't know that one. But so right here, impedance, right? So let's see. Impedance all right, so you can get a market that works. So now we have an unknown resistance and an unknown impedance. When the circuit is connected to when the circuit is connected to a 480 volt source, right? the pure resistance draws, right? So the pure resistance draws 10 kilowatts, right? And right, so okay, and the unknown impedance and the unknown impedance draws what? We know it's 40 kilowatts, right? So with that being said, okay, the power factor, okay, the power factor is 80 is 0.8, right? So now the question is, this is a problem statement, right? So what will be the order power factor? What will be the overall power factor? All right, so that's what they're asking, right? They're asking for this, right? So let's knock this out real quick. Okay, so what is given to us? The voltage, the power, right? The real power, and we assuming that this is CL, right? That means that it's a C is impedance, which in theory there will be another power over here, which is, some type of complex power, right? But they're giving us in this form too, which means that we are given the two real powers, one that include one for the pure resistance and another one for the impedance. Two real powers, right? So now what we do with this is that, okay, so we have this, we have that, right? Now, what can we do? Okay, so now what we can do is basically say that find the angle that corresponds to this power factor, right? So data, okay, we find data old, right, is equal to question mark. We need that. We need data old, right? We have the power factor. We don't know based on this what will be the next power factor, right? Because we are going to have two different things combined here. So we know data. We know the power factor. We need data old. So data old is going to be equal to the inverse power factor, right? Is equal to power factor is equal to cosine of data, right? Now, then I can say that data is equal to cosine inverse of the power factor, right? So now what I can do is take the inverse cosine of that, and I get cosine inverse of, what is the power factor? Old. Power factor old is 0.8. So inverse of that, right? And that will give me my data old, right? So data old. Now, so once I do that, I get cosine inverse of 0.8 is 36.86. So that is data old is equal to 36.86 degrees. Right. Now, that is my data old. Now, I can use the data old to calculate other stuff, isn't it? Now, right here, okay, so we have the data old, right? Now, what we can do is do a little power triangle. So let's say that this is what we're looking at. Right. We have the data, right? So it's 36.86 degrees. Right? Now, what do we have? We have the real power. So we have it right here. We have 40 kilowatts. Right. Now, what do we have here? We don't know. That we're looking for Q, right? We're looking for Q. Okay, so based on that, what else can I do? Right? Because what I can do here is say, okay, so if this guy, remember the tangent of data is equal to opposite, right? Opposite over adjacent, right? Which is equal to sine over cosine, right? Okay, so now based on this, what do I have? I have something back here, right? So technically, I can say, okay, I can just say that adjacent, put A, well, that's just A, right? Times tangent of data is equal to opposite, right? But what is opposite? Opposite is equal to Q, right? That Q right there, that's the opposite. Now, when I do that, I say that, okay, so let's make that Q then. So A is A tangent of data is equal to Q, right? So what is that? Well, opposite is, adjacent is 40. So 40, right, times the tangent of data. But now what is data? Data is 36.86, right? Is equal to Q, right? So now, remember that you can call this is Z, QZ. You can call it as C, right? We're just dealing with the impedance right now, right? That's what we call a Z, right? Whatever is going on to this piece, that's is what we are calculating at the moment. Okay, so 40 tangent of the answer is equal to 30. So it's telling me that the Q is equal to 30, right? And 30 what? Well, it's going to be K bar. So we could call it K bar. Right. Now 30K rise belong to this side now, right? So now, but they asking for what? What is the overall power factor? Which means the overall power factor has to include this 10K. So what I can do is draw another power triangle, right? Draw another power triangle, right? And I can say that this power triangle is going to have 4K kilowatt plus 10 kilowatt, right? And over here, I know that that is going to be 30 K bar, right? And this is SZ, and this is data. Okay, so now, based on this, remember, I don't know the data, right? So we don't know data new. Why? Because this is going to change now. This is going to change. So data new is equal to question mark. Okay, so now what is data new? Well, data new is going to be equal to this plus this is going to be 50. So it's going to be 50, right? $50 kilowatt. Now, having that, what I can do now is I can say that tangent, or I can say that data is equal to tangent inverse of 30 over 50, right? Which is going to be equal to inverse tangent of 30 divided by 50, and it's going to be 31 degrees. So data is going to be equal to 31 degrees, right? So now data new, right? So data new is equal to 31 degrees, right? Now we can use this data new to calculate the average power, right? The power factor, average power factor, the overall power factor, which is going to be power factor, right? Overall power factor, right? Is going to be equal to cosine of data new, right? Right? So power factor is going to be equal to what? It's going to be equal to cosine of 31 degrees. So power factor now is going to be equal to power factor over power factor, right? This is the final answer, which is going to be 0.86. 0.86, right? And makes sense because this power factor is higher than the one that we had, right? We had a 0.8. And the reason why is because we incremented the real power by 10 kilowatts. You can see we incremented by 10 kilowatts. That's why we have a better power factor, 0.86. Okay, so now that is the final answer for that problem. Okay, so that was not bad, right? Not bad. I mean, good problems, right? So now let me do another quick problem. It's going to be another quick one. So as you can see that this problem, if you have the techniques of trigonometric functions and all that, and know and have an idea how the power factor work in relation with the real power and the complex power, and it's not really bad. And so okay, so let's do this problem. The next problem says the following. It says an ideal single phase transformer, an ideal single phase transformer, an ideal single phase transformer is rated at at 440 volts, right? 440 volts, like that, and 110 volts, right? 440 volts. Okay, so the primary voltage is the primary voltage is 480 volts, right? And the secondary load is resistive, right? And the secondary load is resistive, right? Resistive, right? And the secondary load, is, let me secondary load is 5.5 ohm resistive. Right? Now, what else? What is the actual primary and secondary current? Question is, what are the actual primary and secondary current? That's the question. That's what we're trying to find, right? Now, so let's do this, right? So what we know? What do we know about the problem? We know about the ratio of the voltage, right? We know about the resistive load in the secondary. And if we know the ratio of the voltage, we know the primary voltage and the secondary voltage, right? So ratio, you can say that voltage ratio is what? Is 440 volt, 110 volts, right? So what else we know? We know resistance on load is 5.5 ohms, right? So we know this, right? We know this. We know this things. Now, what we don't know is the current, right? So what we can do is that we can find A. A is equal to, and when we do this, it's do whatever, do the ratio, do as it is here. So in this case, it's going to be BP over BS, right? So A, so it's going to be like, usually it's like that. So A is equal to what? We're trying to find the ratio on this, which is going to be what? It's going to be 440 over 110, which the ratio is going to be 4, right? Right? Now, what? So A now, A is equal to 4, right? Now, if A is equal to 4, then we know something already, right? Now, what else can we do? We know this, right? And we know the secondary, right? So, which means that I secondary, I know this is the secondary, right? The resistance. And I know this is the voltage in the secondary. So it's going to be I secondary is going to be BS over R secondary. Which is going to be what? It's going to V secondary is going to be 110 over 5.5, which is equal to it's going to be about 20, but let me just verify. So 5.5, 20 amps. 20 amps. All right. So now, look at this. So we have 20 amps, right, in the secondary. One thing that you can actually notice over here is that you can say that P primary, right, is equal to P secondary, right? You can use this definition, right? If we can play with some numbers and come up with something, right? Now, what else can we do, right? So we know the ratio, we know this, right? Now, can we also say that A is equal to IP over IS, right? Primary over the secondary, right? If we do that, right? So if we do that, we can get, as you know that I know the secondary, but I am looking for the primary, right? So what I can say is that secondary or primary, right? Because I know the secondary, I know the secondary. I know the secondary, and I know this, right? Secondary is equal to that. So I think so IS over IP, right? So what I can do is the following. So I know that this is I know that this is 20, right? And this is actually 4, right? But what I can do is that actually as a reverse is S over P, right? So I am looking for this guy, right? I know that. So I can manipulate this and I can say that I primary, that's what I'm looking for, right? Is equal to I secondary over A, right? So with that being said, that's over A, so I primary is going to be equal to 20, right? Over 4, and it's equal to 5. It's equal to 5 amp. Okay, so now, you can see that if you take 5 amps, times 40, right? And then you can take 20 amps, 20 amp times 110. This is what I'm trying to say, right? power primary is going to be equal to power secondary. To check this, right, if the answer is correct, you can say that power primary is equal to what? Power primary is equal to IP times BP. So power primary is equal to what? It's equal to 5 times what? 5 times 440, which is equal to right? So 2200 what? Right? Now let's do the secondary. Secondary power secondary is equal to what? It's equal to 20. It's, well, in this case, it's going to be equal IS times BS, which is equal to 20 times 110, and it is equal to 2200 watt. Right? That's why I say the power of the transformer, power of the primary, the power of the primary is equal to the power of the secondary. Once you can prove that, you can, if you have the right answer, you will know that this makes sense, right? Because if this answer just does not certify this, the problem is wrong, right? The answers are wrong. But anyway, so we verified those are the right answers. So the primary is a 5 amps, right? Primary equal to 5 amps. Secondary equals 20 amps. Right? And also another thing that makes sense here is that another thing that makes a lot of sense is that the primary, the higher the voltage, the lower the current. Primary, you have 440 volts. In the secondary, you have only 110 volts, and you have 3 times more the amperage. Okay, so that's it for today on this little problems that we have done. Remember that this is the Conservative Engineering Academy, and over here we praise the Lord. And also we are, that's why we call it Conservative Engineering Academy. We praise Jesus, and we are a pro-life. That's why we support President Trump. Despite of what you think, right? Because technically what you think about us, about me, I don't care. Don't care at all. So at the end of the day, what matters for me is Jesus Christ. Everything else is temporary. Thank you for watching, and I'll see you in the next video.